Hello everyone, welcome back to another session by K21Academy, and today our expert trainer will be discussing about Kubernetes health check probes. So watch the video till the end.
Pod has a status which is an array. It tells you the conditions if in the Boolean format, in the true or false. It tells you what condition your pods have passed through. We can find this under describe. When you go and look at conditions like pod schedule, it tells you if the pod has been scheduled on a node or not, true or false, and it tells you if all the init containers inside your pod have completed, that's true or false. And if the containers inside your pod, you can have multiple containers, are those containers in the pod are ready. And then it also tells you another status called as ready, where your pod is able to serve requests, it's able to accept requests, and it can be added to the pod pool out there, added to the endpoints of your service. If then we can see this ready status when you do kubectl get pod, it shows you in the running state, right? And this is what it looks for, and tells you if the pod is ready, can the traffic be sent to it or not. So ready condition is the one which tells if your pod is ready or not. But there can be applications where you spin up a container, the container comes up, but your application is still starting up. Your application is maybe still warming up, it's still booting up, and then maybe it does few things. If you remember we did Jenkins when we did Docker, and we set up the container came up, we tried to exec to it, we tried to log into it, it came back and told us we tried to access Jenkins at the specific port, if you remember vaguely, which said, hey, hold on for some time, the Jenkins server is getting initialized. It took us like good 35-45 seconds for my application to be made available, right? But kubelet does not understand that. It looks for this condition which says ready, which is when the pod comes up, when your container comes up. But inside that container, inside the pod, your application can be still loading up, still warming up, and it might take some time, right? Usually what do? You deploy an application, expose that to a service, and what will happen is service will start sending traffic to the pod immediately. As soon as it sees the status as ready, it'll start sending the traffic to that pod. But here, the scenario is my application is taking some time to warm up. It's maybe writing some logs or creating some locks out there and maybe reading some configs, maybe whatever it is doing, right? And it takes some time. And I do not want traffic to be sent while it is loading up. What happens if the traffic is sent to it? It's not able to serve the request, and then it's going to be an error out, right? We do not want that to happen. We understand our application. By default, this ready, the moment the pod comes up, it says it's set to true. As soon as the pod comes up, and it shows as running as ready status, the endpoint, the IP address of that particular pod, if it is matching your services label selector, will be added to that particular service endpoint, and the service and the traffic will be randomly sent to this pod. We do not want that to happen because my pod is showing as ready, but my application is still not ready yet, right? We don't want to get into a situation where traffic is arriving to our pod and it's not able to serve. What can we do? We need to delay that. We need to delay adding our pod to the endpoint, service endpoint. What is happening is the endpoint controller is constantly evaluating, is there any pod out there matching my services label selector? And the moment this pod comes up and it stores in the ready state, it assumes the pod application also is ready, and adds that endpoint to your services endpoint, and the traffic will be sent. We do not want that to happen, right? So what can we do is we can make use of probes or tests. We can tell our kubelet, if the test is successful, that is when you assume that your pod is ready and it is ready to accept the request. There are 3 probes what we have, which kubelet can perform on your pods and then take various actions on that. What are those? We have starter probe, we have readiness probe, and we have liveness probe. Probes, like the English word, like the test, right? You can probe and see what's going on out there. What do these do? Readiness probe checks if your application is ready to accept your incoming traffic or not. If I don't define the readiness probe, we haven't done that so far in any of our pods, default value is true. The moment the pod comes up, the readiness probe is also set to true, and the traffic and that IP address of the pod is taken, added to your service endpoint, and traffic is sent to your pod. We don't want that to happen. Instead, what we can do, we can define some probe, some sort of test. There are 3 of them. We will come to it. And only when the probes successfully complete, maybe when the application comes up, I want to test it. If the application maybe, is, for example, my application comes up and when it is finally ready and start accepting, it'll write a lock file. Jenkins.log at var lock, some location out there. And when I see that log file is when I know my application is ready. So maybe I can define a test which says, hey, go check for this file. Only if this file is present out there, that means this application is now ready to accept the traffic. And then you go add this pod out there to the service endpoint and send traffic to it. I'm making use of an example of Readiness Probe, which will tell you if your application is ready to accept or not, whether the endpoint of this can be taken and added to your services endpoint is what Readiness Probe does. We also have Liveness Probe. What does it do? It checks if your application is alive or not. What do I mean? Well, your application is running. And if I go back and look at the kubectl get pod status, or that is showing as running for me, everything is fine. But the process inside your application, inside your container, maybe is holding on to a latch, or maybe it's holding on to, running an infinite loop, or maybe, it's a deadlock kind of a situation, deadly embrace, where it's really not doing anything because it's waiting on somebody else and it's just in a hung state. Maybe we need to restart that particular container so that it can start working fine. But from the outside, from the kubelet point of view, it looks at the pod status. It shows as running. It assumes the application is fine and it keeps sending the traffic to it. But our application process can't do anything with that and it's going to error out. We don't want that. We want to check. It's showing as running, I know, but I want to probe and see if my application is alive. Is it healthy out there? If not, I want to take action. I want to restart my container. That's what your liveness probes does, right? If it has got a deadlock, maybe a restart, it gets resolved, right? The container restarts cleanly and then we can make use of that. Similar, we also have another probe called a startup probe. Checks if my application container is started or not. When we define startup probe, what startup probe does is it disables your liveness and readiness probe. The name suggests the startup probe, it checks for your container is started or not, right? If you define all of them together, and when first will be the startup probe executed, and it's going to disable your readiness and liveness probe until your startup probe goes through. Once it's successful, that means your application is up and running, it is started. Then you can do your liveness or readiness probes along with that, right? There might be applications which have slow starting containers, and we don't want them to, traffic to come to them. So we can make use of combination of liveness and readiness probes and startup probes and define what happens to our application pods, right? But how do we define this? How do we test this? What kind of probes do we have? What options do we have? We have a couple of options. What? We can do an exec action. We can do TCP socket action and HTTP GET. For example, you're running a web server where you can perform a HTTP GET on a specific path. And if it returns back with, say, 200 to 400 as a written code, that means it is successful. And any other written code, meaning that it is not gone through, right? It's failure. Right? And then you can also do maybe a socket, right? Perform a TCP check against a port IP address in a specific port. Your database, for example, listens at particular port. You can check for that socket and see if that socket port is open, that means your application is up. Or you can do an exec action. You can execute any command. Like, for example, I was discussing, like I'm going to write a log file out there. So if I can do a ls command and see if there is a log file there or not. If it is there, then the probe is deemed to be successful, right? And you have three options. You can make use of any of them, and how to make use of that is what we're going to take a look at it right now. And you have some additional options as well. Before you want to start probing it, you can add something called as initial delay, where it is not going to probe right away the moment your container comes up. It's going to wait the initial second. Maybe like for example, we look at a Jenkins application, it takes like 30 seconds to warm up. So we don't start probing as soon as it comes to ready state. Instead, we wait for the initial delay seconds, and then we try to probe it. And we can also define a period interval. In what interval we want to keep checking it, right? And you can define the period in a number of seconds, and then based on that, it'll keep probing it. For example, for liveness probe, if I say interval of the period is 10 seconds, every 10 seconds is going to do the liveness probe, and if the probe fails, the container will get restarted. Like in the readiness probe, for example, if the probe fails, it's going to take it away. It's not going to add that particular pod to your service endpoint so that the traffic does not come to your pod, right? So those are a little bit of probes what we have. Startup probes indicates whether your application is started or not. Like I said, all probes will be disabled if this is provided. And if it fails, the kubelet will kill the container, and it is whatever your restart policy is, default is always, it is going to get restart it. When you don't provide any probe, the default state is always success. That's true for all of them as well. Similar with Liveness Probe as well. If it fails, the kubelet kills the container based on your restart policy. And the Readiness Probe, if it fails to respond, it'll be removed so that from your endpoint of your service so that the traffic does not come to it. Right? So you can make use of a combination of Readiness Probe and Liveness Probe, and where it checks if the pod is alive or not in between, if so your container is alive or not, and it also checks if for the readiness initially to add it to your service endpoint. So that's a little bit about Readiness Probe, Liveness Probe, and Startup Probe.
So guys, this was our expert from Team K21 Academy, and if in case you want to have a deeper dive and want to build a career in Kubernetes and Docker, including DevOps, then we have something really special for you. We have our free class on mastering Kubernetes, Docker, and DevOps that includes how to build in-demand skills and land a high-paying job. So for that, you just have to visit k21academy.com/K8S02. You have to click on book your free seat now. And after that, select an event date according to your availability. Enter your name, your email address, your phone number, and click on yes, save my seat. Moving ahead, you'll be seeing this kind of interface. You just have to save this link on the extreme right, add it to your calendars, and I'll see you in the free class. Till then, take care and keep learning.